This time, I will talk about building a survival analysis model in Python. Survival models, like the Kaplan-Meier Estimator and the Cox Proportional Hazards Model, provide insights into how long individuals or groups are likely to survive over time. These models help us predict life expectancy and estimate survival chances at different ages or under various conditions. Those models can be used in several scenarios. First, for healthcare, survival analysis helps predict patient outcomes, including lifespan estimations and the impact of treatments on survival. In insurance industry, those models are used in actuarial science to predict life expectancies, determine insurance premiums, and assess the risk of insuring an individual. Public health use those models to identify at-risk populations and evaluate the effectiveness of health interventions. I got the data for my model from this paper. If we take a look at this paper, you can see this is a paper. This is actuarial study number 120, and you see they have all the data listed here. This paper is available on the internet, so if you want to read it, you can just search for this paper and download it and read it. My model's goal is to analyze and forecast survival probabilities using life expectancy data from male and female cohorts. I used two methods. One is Kaplan-Meier Estimator, a non-parametric method to estimate survival probabilities over time. The second method is Cox Proportional Hazards Model, a regression model to investigate the relationship between survival and covariance such as sex and age. The data used is life expectancy tables with data on age, death, and total person years. Again, you can find all those data in the paper I just mentioned before. First, I will process this life expectancy table, and Lx is number of people surviving each age, and dx is the number of deaths at each age, and tx is the total number of years lived by all individuals from a given age onward. And this survival calculation is proportion of people surviving at each age. Mortality rate, this Qx, is probability of death at each age, calculated as dx divided by Lx. And the output of my model is saved as CSV file for further analysis. Life tables for male and female are handled separately and then combined for joint analysis. I will upload my Python model into my GitHub so you can download it, run it, and generate all those results and check it out by yourself. Then what is Kaplan-Meier Estimator? The Kaplan-Meier Estimator is non-parametric statistic used to estimate the survival function from lifetime data. It calculates the probability of surviving in a given time interval, taking into account censoring, because individuals whose exact survival time is unknown. This is a formula for the Kaplan-Meier estimator. You can see here, we take a sum before t, and ti is the event time, and the di here is the number of deaths at time ti, and ni in this denominator is the number of people at risk just before time ti. Then we'll get this survival function. The key outputs are Kaplan-Meier survival curves by sex, showing the probability of survival over time. And in my model, this survival probability are plotted against age. In my model, separate survival curves are calculated for males and females based on life expectancy data. The x-axis represents age, and the y-axis shows the survival probability. And I also generated this graphics for the output, and you can take a look. I'll show you later. Now let's take a look what is Cox Proportional Hazard Model. The Cox Proportional Hazard Model is a regression model used to explore the relationship between the survival time of the individuals and one or more predictor variables. It calculates hazard ratios, which represent the effect of covariates on the risk of an event happening. This is the formula of the hazard function. You see here, this is hazard function equal to the baseline hazard over years since entry t, and the beta 1 and beta 2 is the Cox coefficient. And you see this is sex code. 0 means male, 1 means female. And this age at entry means age at interval start. The key output from this Cox Proportional Hazards Model is, first is hazard ratio. It estimates the relative risk for each covariate, i.e. the effect of gender and age. The model's results, including hazard ratios and confidence intervals, are saved to CSV and plotted as hazard ratio plus. Now, let's go to my Python code to show you my model. This is the model I developed in Python. You can see this function will load this life table. I have all those descriptions here, so if you download this code from my GitHub, try it, and you can read these instructions. and this will build this KM dataset. This will build the Cox dataset, and this is main function. We load the table, and then we build the datasets for the Kaplan-Meier and also for the Cox model, and then we just calculate and plot the results. Now let's run our model. This is the results of my Cox model hazard ratios. You can see here age at entry is plotted around this 1.05. That means for each year, the later date at entry will increase risk about 5%. And this sex code, remember male is 0 and female is 1. So we can see if it is a female, the risk or the hazard will be lower, about 14%. And this bar is 95 confidence interval. And also here I also plot the 95% confidence interval, but it's pretty tiny. It's inside this black box. And this is the result of the Kaplan-Meier survival by sex. You can see male is this line and female is this blue line. Obviously, you see the male's line drop faster, so it shows it has more risk than the female. This is how you can build a survival analysis model in Python. Please comment, like, and subscribe to my YouTube channel. Thank you for watching.